The ground beneath our feet may seem stable, but it's part of an ever-changing dynamic system. The Earth is alive with movement, and at times, it reminds us of its immense power through one of nature's most awe-inspiring and terrifying events: earthquakes. What causes these dramatic shifts in the ground? How do they reshape our planet? And most importantly, how can we understand and prepare for them? Today, on the Knowledge Arc, we explore the science, history, and impact of earthquakes, unraveling the mysteries of these natural phenomena. At its core, an earthquake is the sudden release of energy stored deep within the Earth. This energy is unleashed when stress along cracks in the Earth's crust, known as fault lines, reaches a breaking point. Think of the Earth's crust as a massive jigsaw puzzle made up of interlocking pieces we call tectonic plates. These plates move slowly over time, sometimes grinding against one another, sometimes colliding, and sometimes pulling apart. When this movement becomes stuck, stress builds up like a stretched rubber band. Eventually, the stress snaps, sending powerful waves of energy, seismic waves, rippling through the ground. This is what we experience as an earthquake. To understand earthquakes, we must delve into the structure of our planet. Beneath the Earth's thin, solid crust lies the mantle, a layer of hot, flowing rock. Floating atop this mantle are tectonic plates, constantly in motion, driven by heat from the planet's core. These plates interact in three primary ways. At convergent boundaries, plates collide, creating immense pressure that can result in violent earthquakes and even form mountain ranges like the Himalayas. At divergent boundaries, plates move apart, allowing molten rock to rise and form new crust, often accompanied by smaller earthquakes. And then there are transform boundaries, where plates slide past each other. This is where some of the most infamous earthquakes occur, such as along California's San Andreas Fault. Here, the grinding movement releases energy in sudden, powerful jolts. How do we measure something as dynamic and unpredictable as an earthquake? Scientists use specialized instruments called seismographs. These devices record the vibrations caused by seismic waves, creating a visual representation of an earthquake's intensity and duration. The strength of an earthquake is quantified using scales like the Richter scale or the moment magnitude scale. These scales are logarithmic, meaning each step up represents a significant increase in energy. For example, a magnitude 7 earthquake releases about 32 times more energy than a magnitude 6. Another critical measurement is the quake's depth. Shallow earthquakes, occurring within 70 kilometers of the Earth's surface, tend to cause more damage, while deeper ones dissipate much of their energy before reaching the surface. The effects of earthquakes can be as varied as their causes. Minor quakes might only cause slight tremors, barely noticed by most people. But major quakes can unleash devastating force, toppling buildings, cracking roads, and tearing apart landscapes. One of the most destructive secondary effects of earthquakes is the tsunami, giant ocean waves triggered by underwater seismic activity. These waves can travel across entire oceans, striking with little warning and causing catastrophic flooding. Beyond their immediate impact, earthquakes also reshape the planet over geological timescales, forming mountains, valleys, and other features. They're a reminder of the Earth's power to both destroy and create. Some areas of the world are far more prone to earthquakes than others. The Pacific Ring of Fire, a horseshoe-shaped zone encircling the Pacific Ocean, is home to about 90% of the world's earthquakes. This region includes countries like Japan, Indonesia, and Chile, where tectonic activity is a daily reality. Other notable earthquake hotspots include the Himalayan region, the Mediterranean, and parts of the Middle East. Understanding these high-risk zones helps scientists and governments prepare for potential disasters, implementing building codes and early warning systems to mitigate damage. Predicting earthquakes remains one of science's greatest challenges. Unlike weather patterns which follow observable trends, earthquakes are sudden and unpredictable. However, scientists can identify areas with a higher likelihood of quakes based on tectonic activity and historical patterns. Early warning systems are also making strides. These systems detect the initial, less damaging waves of an earthquake and send alerts before the stronger waves arrive. While the warning time may only be seconds, it's often enough to take cover or shut down critical infrastructure. When an earthquake strikes, your actions can mean the difference between safety and danger. If you're indoors, drop to the ground, take cover under sturdy furniture, and hold on until the shaking stops. Avoid standing near windows, mirrors, or heavy objects that could fall. If you're outside, move to an open area, away from buildings, trees, and power lines. In coastal regions, always be alert for tsunami warnings following major quakes. Remember, preparedness is key. Keep an emergency kit handy and know your area's evacuation routes. Earthquakes are a testament to the Earth's restless energy. They remind us of our planet's incredible power and its role as a creator and destroyer. By studying these natural phenomena, we can better understand the dynamic forces shaping our world and take steps to protect ourselves from their impacts. Thank you for joining us on this journey. Stay curious, stay informed, and subscribe to the Knowledge Arc for more deep dives into the wonders of science and nature.